Welcome back. We are now in part 7b. So we're moving into a new concept that is extremely important to understand to be able to talk about a specific type of reaction called precipitation reactions. So before we even go into precipitation reactions, let's make sure that we understand and master the concept of solubility. By the way, chapter 14, if I remember right, is going to be all about solubility. This is just a very brief introduction into it, just related to chemical reactions. So what we're going to learn is how to determine if a compound is soluble or not. And since this planet is about 70% water and your body is about 70% water, we're going to assume that most of the time we are dissolving in water. So we're talking about solubility in water, which will make any atom, when you put it in water, it's going to make it aqueous from the Latin letter for water, aqua. So that's what we're talking about. Compounds that can dissolve in water. They basically disappear in the water. So a lot of people have been doing studies about this. So they have developed tables that tell us which ones are going to dissolve or not. We just need to apply the rules. So for example, any compound that contains lithium, sodium, potassium, ammonium, nitrate, acetate, and the halogens chloride, bromide, and iodide, they're going to be soluble. If you put them in water, they will dissolve. Specifically, the first two rows. There's no exceptions. The third row, you gotta be careful because the third row, most of the time, they will dissolve in water, except when the anion, remember those are negative charges, right? When the anion is accompanied by the cation such as silver, mercury 2, or lead 2. That will make them insoluble then. So that would be the exception to the rules. Same with the sulfate. If you have a compound that contains sulfate, it's going to be soluble unless it's with calcium, strontium, barium, or lead. I do not intend you to memorize this. Hopefully, you will learn it by doing it a lot, but this table should be one of your tools. You should have this table available with you. So I will make sure it shows on the first page of the test so you can refer back to it. But as you do it more and more and more, you will memorize them without even trying. That's even better than memorizing. What about the insoluble ones? So every time you see a compound that contains hydroxide or sulfide, it's going to be insoluble unless it's accompanied by the alkali metals or ammonium. Then they will be soluble in that case. The same thing with if you have sulfide, not hydroxide, but sulfide, with calcium, strontium, or barium. So most of the alkaline earth metals, then it will be soluble. When hydroxide is with calcium, strontium, and barium, the compound is just slightly soluble. So it will dissolve a little bit, but not much. And then every time you have anything with carbonate or phosphate, it's going to be insoluble unless once more is with an alkali metal or with ammonium. So every time you see anything with an alkali metal or ammonium, it's going to be soluble. You can put that on the bank. So we're going to keep referring back to this table as we do problems until we develop a really good feeling for it. So let's start with this problem. Pair each cation on the left, so this one's here, with an anion on the right that will form an insoluble compound. And write the formula that comes out of it. So let's just do silver with all of them. Actually, let me go back and bring the table so I can refer back to the table really easy. So let me clear the table first. Now let me go ahead and copy the table. And let's bring it over here. Just put a shortened version of it. So, what happens if I get silver and sulfate? All sulfates are what? All sulfates are soluble, except with any of those. Silver is not in there. So what I'm gonna do, I'm gonna set up two columns here. This is gonna be the soluble, and this is gonna be the insoluble. So when I have silver with sulfate, it's gonna be soluble. And silver is +1, so that would be my formula by doing crisscross. Silver with chloride, I know that silver with chloride is gonna be insoluble. So if I have chloride with silver, it's gonna be insoluble. And I know that one from memory because I have done it so many times that I already memorized it. What about silver with carbonate? That's gonna be insoluble. And that would be the formula. Silver with sulfide. All sulfides are insoluble, and silver is not one of the choices there. So that's everything that happened with silver. So let's try now barium. Barium with chloride. When I check on the table, that's not in there, so barium with chloride is gonna be soluble, and that would be the formula. Barium with sulfate, that's gonna be insoluble, because it said that all sulfates are soluble unless barium is one of the choices that will make it insoluble, an exception. Barium with carbonate, or carbonates are insoluble. So barium carbonate, that would be the formula. And barium sulfide, the sulfides are insoluble. When paired with barium, the compound is soluble. So barium sulfide is soluble, according to the table. Remember, this is my soluble part. This is my insoluble part. Let's do copper now. All sulfates are soluble. So copper 2 sulfate is gonna be there. Copper chloride is gonna be there also. Copper carbonate, that's gonna be insoluble. And copper sulfide, all sulfides are insoluble, and copper is not one of the exceptions. And last but not least, iron. All sulfates are soluble, and iron is not an exception. So Fe3 plus combined with sulfate 2 minus, Fe2, SO4, 3 of them. So that's going to be soluble. Fe, SO4, Fe2, SO4, 3. Iron chloride, that's going to be soluble also, and it's going to be like that. Iron 3 carbonate, or carbonates are going to be insoluble. So that's going to be insoluble over here. So that's going to be Fe2CO3 3. And iron sulfide, also going to be insoluble. It's going to be 2 and 3. So we were able to find out all the ones that are going to be insoluble by just using the table that I showed you. And that's going to be super important for the next objective when we start talking about precipitation reaction. For you to be able to decide, yes, this will be insoluble, this will be a solid. So you should be able now to do the same thing with your daily work. So basically, move them around and put them on the right column. And then you should be able to do that also. Find out which one is soluble or insoluble, and tell me which ions are forming them. So for example, if it was silver chloride, the table will tell me that this will be insoluble, so it's going to be a solid. Do not confuse the S with soluble. This is the S for solid. Insoluble means that it's going to be a solid. And the ions are for the soluble compounds, so you don't have to do the ions for this one because it's solid. But if I have silver nitrate, that's going to be soluble because all nitrates are going to be parts of soluble compounds, and it's going to break, and the ion will be Ag plus, and the cation is Ag plus, and the anion is nitrate. So that's what this is telling you to do. And with that, that's all you need to determine if a compound is an ionic compound, if an ionic compound is going to be soluble in water or not. So we're going to leave it there for right now. Next time, we're going to come back and use that to be able to do the next concept, which is precipitation reactions and predicting the products of a precipitation reaction. Until next time, see you soon.